All right, so now that we've gone over the formulas for volume, let's talk about how we are going to apply these formulas. So let's start with a cone. So it says find the volume of the cone, round your answers to the nearest hundredth if necessary. So if we look at this cone, we have a cone that is 12 yards across on the bottom, and this 12 yards is the height. So you can tell it's the height because there's a 90-degree angle right here. If you don't have that, you don't know whether that's a height. So let's talk about how to find the volume of this cone. So to find the volume of this cone, we need to use the formula, which the volume for the formula of a cone is the area of the base times the height divided by 3. So first we have to find the area of the base. Since this is a cone, the base of it is a circle. So the area of the base is going to be pi r squared. Well, what's r? 12 yards is our diameter. So we need to take the 12 and divide it by 2 to find our radius. So our radius is going to be 6. So the area of the base is going to be pi times 6 squared, which is 6 squared is 36 pi. And then the volume is the area of the base times the height divided by 3. So we're going to do the volume equals the area of the base, which is 36 pi, times our height of 12 divided by 3. And then this is the part where we pull up our calculator. So you're going to do 36 times 12 times pi divided by 3. I got 452, and it says round to the nearest hundredth, 0.389, so it's going to be 452.39. Now, on the test, if you left your answer just like that, that's not 100%. That's like a B. You need to put the units. So we've been working in yards. So since this is volume, it's going to be yards to the third power. So 452.39 cubic yards. So just don't forget that for volume, it's going to be cubic yards. So that is the volume of that cone. So the next type of shape I want to talk about is composite shapes. So really, this that we just did here, just finding the volume of one shape, that is something that really you should have been able to do in middle school. So for a high school level standard, we need to be able to do composite shapes. So you might have something like this where you've got a pyramid and a rectangular prism, and it's called composite because literally they're just put together. So to find the volume of the whole thing, we're going to add them together. So the dimensions of the prism are 32 by 35 by 9 tall. The height of the pyramid is 4 feet. And then we're supposed to find the volume of the whole thing. So I would like to start by finding the volume of the rectangular prism on the bottom. So the volume of the rectangular prism is going to be 35 times 32 times 9, which is 13,230. And we're working in feet here, so that makes sense to me that that's going to be a pretty big number. Okay, so that's like, we need to save that number, but that's not going to be our final answer. So the next thing we need to do is find the volume of the pyramid on top. So the pyramid has a base. So remember, the volume of a pyramid is the area of the base times the height. So for this pyramid, the base is 32 by 35, and the height is 4. So the area of the base is going to equal 32 times 35 because it's a rectangle. So 32 times 35, base is equal to 1,120. Okay, so then the volume is going to equal 1,120 times the height of 4 divided by 4, and then divided by 3. I get the volume is 1,493. That's the volume of the pyramid. So now, in order to find the volume of the whole tent, I just need to add these two numbers together. Volume equals 13,230 plus 1,493. So 14,723.3. And it says round to the nearest tenth, so I just stop right there. And then notice it's in feet. So that's going to be feet cubed because it's volume. And if you're confused about why it's to the third power, remember for the rectangular prism, length times width times height, that's 3 things we're multiplying. For the pyramid, we did length times width, that's 2, and then we did times height, so that's our third. So we have 3 dimensions of space, so feet to the third power. So that's composite shapes. So on the test, that's enough to get you like halfway there. So the next type of thing we're talking about is subtractions. So this is where we have something with a hole in it, usually. So in this case, we've got a wooden post that's a rectangular prism, and there's a hole in the middle. So I want to know just the volume of the leftover bits. So it says that the prism is 7 by 5 by 23. That's written on there. And then it says that it has a hole with a diameter of 4 centimeters. So it's important to pay attention. That diameter means it goes all the way across. So to do this problem, I hope you can see that we would have to find the volume of the rectangular prism, and then we're going to have to subtract out the volume of the cylinder in the middle. So first, let's find the volume of the prism. I'm going to do that in blue. So the volume of the rectangular prism is going to be 7 times 5 times 23. Okay, save that for later. Then we also need to know the volume of the hole in the middle. So the volume of the cylinder is the area of the base times the height. Well, the area of the base of this is a circle. So we need to find the area of the base is pi times the radius squared. Well, the radius is going to equal half of the diameter, so 4 over 2, which is 2. So area of the base equals pi times 2 squared, which equals 4 pi. So then the volume of the cylinder equals 4 pi times the height, which is, this part confuses people because the height of this cylinder is the length of the post. So it's the 23. So I'm going to put that in my calculator. 4 times pi 3 is 289.02. I'm going to save several decimal places so that when I get to the end and I have to round to the 10th, I've got enough decimal places to do that with. Okay, so there's the cylinder in the middle. So to find the leftover piece, I'm going to need to actually subtract those two numbers. So I'm going to do, to find the final volume, 805 subtract 5, and I get 515. Ooh, that one's one of those tricky ones to round because I'm rounding to the nearest tenth. But see how it's 0.9735? That 7 is going to make that 9 bump to a 10, which actually makes this 5 bump to a 6. But since it's to the 10th place, we do have to leave a 0 right here. And then I need to look back up and see what my units were. My units are centimeters, so it's going to be centimeters to the third power. So there we have it. This is the method for finding the volume of a subtraction type. All right, we're getting close, but here is how to find volumes of subtractions with more complicated, like a cylinder. A sphere. This is not a cylinder, this is a sphere. So for whatever reason, spheres tend to be difficult for a lot of people. So let's do this example. We're supposed to be finding the volume of the material that makes up the ball. So we're just finding the outer shell of this sphere. And it tells us that the outer diameter is 50 centimeters. So from one outside all the way to across to the other outside. It says that the thickness, so the thickness of the material is 0.75 centimeters. So the real trick with this problem is that we have to do a little bit of math to find the inner radius. So the outer radius would be half of 50, which is 25. the inner radius, you have to subtract out that 0.75. So I'm going to do 25 subtract 0.75, which is 24.25. So then we just have to find the volume of the outside circle, sphere, and the volume of the inside sphere, and subtract them to find the amount of material we would need. So first let's do the outer sphere, and that's going to be 4/3 pi r to the third power, which is 25. So 4 divide 3 times pi times 25 to the third power. And I got 65,446. And then the inner sphere is the same formula, 4/3 pi, but then it's going to be times 24.25 to the third power. So 4 divide 3 times pi times 24.25 to the third power is 59,734. So now we just have to subtract those two numbers. 65,449.69 subtract 59,734.17. I got 5,715 point nearest hundredths. 54 centimeters cubed. So there we go. That is how we find the volume of the shell of a sphere. So these are what I would call your basic subtractions and compositions for finding volume. So I'm going to go ahead and cut this video off here, and I'll have another video to go over the more complicated types of volume problems.